V capital G. Ooh. Okay. Yeah, still did not make any. Okay, let's just use our thing, which we got. Where was it? Create a window. Um, is it something that got deprecated? Huh? I guess glad load GL got deprecated, and this is something that I have to use now. Load. Mm, hey, come on. Make. Yeah. Make OpenGL app. Somehow this works. Somehow this works. Fuck. This is the first time that I got a result that I wanted. I'm still not satisfied. Fucking hell. Shut up, let's just. Man, this is so fucking disappointing. This is so fucking disappointing. To watch this happen, it's disappointing. Oh, damn. Hell nah. Hell nah, brother. Hell nah. But, oh, I see it's an equilateral triangle with a good specs. But no GG. Let's. Should I be happy about that? Oh, Lord. I mean, you're just trying to cheer me up. I know that. But for God fucking sake, I just copy pasted someone else's code and it works. And I wrote the same shit for past, what, like, how long? Past 1 hour, it doesn't do shit. Cool. Cool, cool, cool. That's my start. I start by cheating. Huh? What do you say, man? I could load my thing on. Let's just read it once more to make more sense. Uh, create a vertex shader object. It's a reference, yes. And GL shader source vertex and compile shader. Compile shader, compile shader, compile shader, compile shader, compile shader. Fucking documentation, man. Mm, mm-hmm. This is my hello world into. Okay. This is my hello world. This is my hello world. So 0.5, 0, comma 0.5, 0, comma 0.5. If I change the coordinates up a bit, should get some deformed triangle. Lower left corner instead of this. If I can do 0.7 f, make. Yep. uh, I can make it a bit more wonky if I want to, but what's the point? What's the point? uh I mean, let's try to have some more fun. Okay. కలయా నిజమా తెలిరేయిలోని మహిమ కలయా నిజమా తెలిరేయిలోని మహిమ. What if I want to render one more triangle? Where am I setting the coordinates here? Mm-hmm. Vertices, where am I using the vertices again? Let's just trace back on the same thing. Why do you feel that if I do something right now, it's gonna fuck the entire thing up on me? It'll crash badly on me. GLFW destroy window, GLFW terminate. I get it. I made a pipeline fine, but yeah, makes sense. I mean, a win is a win. I'll take this cheap win. It's fine. Hmm. Uh, is, is network that screwed? I see my pixels breaking here. I'll just add them at the end and then need to change the stuff in the vertex buffer and draw call. Hmm. Mm, draw. Draw. GL triangle. Mm-hmm. Let's not you know uh move away from the point here. Compiling shaders unsigned and to create GL shader. GL shader. The source. Okay. Int success. Int log. Info log 52. Compile success. Okay. See out. Okay. Fragment shader. I'm taking this a bit more slower than I took Rust. I just jumped on the bandwagon and started to write Rust, and it it's like taking a gun and shooting at my own foot, like shooting your own foot kind of approach. But with graphics, I don't want to pounce on it. Yeah, I'll try taking this step by step. Okay, creating a program object is easy. Mm-hmm. Attach shader, link shader program. After that, delete. Yeah, makes sense. Link vertex attributes. Okay. Function GL attribute pointer. Uh-huh. Got this thing. Got this thing. Unsigned. Okay. Okay. If your output source doesn't look the same way, you probably did something wrong along the way, and check the complete course and see if anything even elements buffer. To draw the second triangle, I can just add in a couple of more vertices. What's the difference in vertex? It's like 0.5, 0.5 F and 0 top right, bottom right. If I just stick this in, will it just know that we started from 0? Okay. Okay. Elements buffer object. There is one last thing that we'd like to discuss when rendering vertices, and that is element buffer object, abbreviated to EBO. To explain how element buffer object works, it's best to give an example. Suppose we want to draw a rectangle instead of a triangle. We can draw a rectangle using two triangles. OpenGL mainly works with triangles. This will generate the following set of vertices. Okay, so if I do this, as you can see, there is some overlapping on the vertex specified. We specify bottom, right, left, and twice. This is an overhead of 50% since some rectangles could only be specified with only four vertices instead of six. This will only get worse as soon as we have more complex models to have over thousands of triangles where there will be a large chunk and that overlap. What would be a better solution is to store only the unique vertices and specify the order at which we want to draw those vertices in that case, we only have to store four vertices for the rectangle and then just specify at which order we like to draw them. Wouldn't it be great if OpenGL provided us with feature like that? Thankfully, element buffer object works exactly like that, and EBO is a buffer just like vertex buffer object that stores indices that OpenGL uses to decide what is to draw. Okay, this is this so-called indexed drawing is exactly the solution to our problem. To get started, we first have to specify the unique vertices that indices to draw them. Oh, oh, we start from zero. Okay. Mm-hmm. You can see that when using indices, we only need four vertices instead of six. Next, we need to create. So, if I do this, will it will it work? I need to just test this theory out. I mean, I'm not successful there, but let me have a shot. Ah. Hmm. What, sir? Wait. Oh, my bad. Pull the entire thing down. Hmm. Format by make. Mm-hmm. That's not something I expected. uh, you still tell it to draw three vertices, trying to change three in GL draw to six. Oh, my bad. Mm, uh, mm, make. You're the man, buddy. You're the man. What are you, brother? I just drawed a square. Finally, I drawed a square. There is a square, proper square. It looks good. It looks really good. Nice. Good one. Proud of you. I'm a dumb programmer. Okay. And let's just change this. Uh, hero. No, not that too. Uh, this would be an accurate name. Oh wait, I have to build it before I make dumb triangle. Yes. Wow. You gotta get used to I3 a bit more, ma. Mm, yeah. Okay. With this, okay. Now let's see. Let's mark our build here. Okay, and so all the Helios calculations, if I don't do any of it, it still works. Mm, good, good. Uh, I don't know. I have the habit of like saving everything, like colon W every single time I open up my editor for at least 10 times redundantly. Do you have that habit, like clicking on something which you're used to? Shouldn't. Don't laugh. Okay. Yeah. Like I'll do this every time I walk into this. I just do this random clicks and save it and go here, save it again. Ooh, move. It just makes me feel fast. Quite frankly, I'm not. Bingo. Mm. Ah, fuck. कलाया निजमा बोली रे ये हाय महिमा. Okay. Let's just go through the documentation again. Okay. Yeah. So instead of going with all the six vertices, uh, I'm just making sure that I render only 4 points by saying that what's the name of this element buffer object. This will handle. Nice. And note that we start from 0 and we go to 0, 1, 3 and 1, 2, 3. And so technically we are rendering 0, 1, 2, 3. Only 4 points. Okay. Okay. You can see that when using indices we only need 4 vertices instead of 6. Next we need to create the element buffer object. Okay. Unsigned in TBO and Glen buffer and 1 and reference to. Okay. And similar to the VBO, we bind the EBO and copy the indices into the buffer with GL buffer date. Also, just like the VBO, we want to place those calls between the bind and unbind call. Although this time we specify GL element array buffer as a buffer type. Okay, I am just using the buffer type and I'm passing in EBO and buffer data. I'm just saying the buffer type and size of the indices. Uh, yeah, size of the indices. It's like what, 2? Uh, 2 and indices. I'm passing in indices and GL static draw. Okay, static draw mentioned. Note that we are now giving GL element array buffer as the buffer target. The last thing left to do is replace the GL draw array call with GL draw element to indicate we want to render the triangle from index buffer. When using GL draw elements, we are going to draw using index provided in the element buffer object currently bounded. Okay. GL GL element array buffer EBO GL bind buffer again, EVO, and GL draw elements. And I'm saying GL triangle 6 unsigned 0. Okay. Unsigned int. Okay. The first argument specify the mode we want to draw, similar to GL draw array. The second argument in the is the count of number of elements. Second argument is the okay. Elements we'd like to draw. We specify 6 indices, so we want to draw 6 vertices in total. The third argument in the type of indices, which of the type GL unsigned it. Okay. Unsigned int. Okay. The last argument allows us to specify an offset in the EVO or pass in the index array, but that is when you are not using element buffer object. Okay. But we are going to leave it in 0. Now, the GL draw element function takes its indices from the EBO uh, currently bounded to the GL element target. This means that we have to bind the corresponding EBO each time we want to render an object with indices, which again is a bit cumbersome. Okay, it just so happens that the vertex array object also keeps track of element buffer object bindings. The last element buffer object that get bound while a VAO is bound is stored as VAO elements, the buffer object binding to VAO, then automatically binding to EBO. Okay, vertex buffer object EBO vertex attribute something attribute pointer 0 will point to position 1. Point 1 and 2 is like 0 1. I don't pretty much understand it. It mostly looks like magic for me, but the result initiation draw now looks something like this. GL binder ABAO initialize code bind the vertex array object GL bind buffer GL array okay VBA and size of the buffer bind buffer bind buffer data vertex attribute pointer will go like this. Enable vertex attribute array draw code use GL use program shader bind vertex array GL GG in renderer loop. Okay. Running the program should give an image depicted below. The left image should look familiar and right image is the rectangle drawer in versus the versus rectangle shows the rectangle uh, indeed consistent of two triangles. Okay. Yeah, makes sense. Wireframe mode to draw a triangle in wireframe. You can configure how OpenGL draws its primitive by a polygon made. GL front and back, GL line. Mm-hmm. The function point sets the polygon rasterization how GL should draw its primitives. Developers can choose to draw the primitives as line or points if they like. Any subsequent calls will use rasterization mode set. Parameters of GL face GL mode as follows. Face specify the polygons that made that mode applies to can take the values GL front, GL back, GL front and back. Specific want to try that one too. Now okay. You can find the complete source code if you have any errors. Nice. Let's see. We got till here. We got till here. Learn OpenGL. Uh okay. GLF set GL load. Oh, the code is updated there. Nice. Unsigned vertex shader. GL compile shader. Build and compile our shader program. Okay. GL shader. Okay. GL get shader info logs. I don't understand this one, but the at the time of this discussion, that doesn't matter. Okay, if success, okay, uncertain shader program create attach shader, okay, boohoo, delete shaders. Okay, oh, this is still the shaders. Okay, from here my actual change will start. The vertices will move from here and answer in VBO, VAO, and EBO. EBO is the addition here. GL generate vertex array, which is 1 and reference to VAO. GL generate buffers 1 and reference to VBO. Okay, I'm creating two buffers and marking them in. GL bind array and GL bind array buffers and okay. I don't think I'll have intelligence better enough to go here, but I get the point. Wait. So after this, after this, where? Find. Okay, where is EBO? Element. Okay, I'm specifying what to draw. Vertex attribute pointer 0 3 0 to 3 and vertex attribute pointer vertex attribute pointer vertex attribute pointer. Okay, wait. Where did I mention 3 here? Then set the vertex attribute pointer to 3. Why? Mm, hmm, mm, looks like I'll get monetized soon. You know, I need 30 more followers. Yeah. So after doing this not so fun thing, maybe because 3 values per vertex. Yeah, 3 values per vertex. Probably. Let's see. Let's see what it does. Uh, mm-hmm. It takes in GL index, GL size. So that's the size of the like, wait, size type normalized GL vertex attribute pointer. Mm, in my case, not here. In my case, it's like size is 3. 3 because what? Because of what? Because of what? Because of what? Because of what? Why is it 3? Why is this 3? What am I passing it? 3 times size of float. Oh, size of float. Doesn't make sense now. It's going side for a bit. If you know what I mean, huh? Okay, GL enable vertex attribute shader. If I can just pull this thing up, it'll work. I know I can just feel this, but this triangle is too good for me to lose. See, this looks good. Sorry, not triangle. I mean square. It was supposed to be a rectangle, but something is better than nothing. Yeah, I don't want to lose this by that easy margin, but let's see. Maybe I can just add a breakpoint here. Not that kind of breakpoint. Just get status. I beefed up the entire project. I know. I beefed it up. You know what? I can just tell. Do I have git ignore? No, I don't think I have. Ow. Okay. I don't think I have git ignore here. So let's just let me make an ignore. What? Git. I forgot. Oh, how do I keep forgetting most easiest stuff? Wait. I can just do HTTP. HTTP might have, since it's a Go thing, LL. Does it have ignore? Yeah, git ignore. So I G N O R E, and I can just do build. Ignore my build and git status. Git add dot git ignore. Uh, okay, wait. Okay, git commit m gg. Really at a good point. Don't mess it up. Okay, git push. Okay, will this work? Okay, git status. Git add all. I'll just save this point and then we'll move. Okay. How do I mistype so regularly? Get a commit. Mm, please don't do anything. Y- your actions are your biggest. How do you spell enemy? N-E-M-Y? Wait, I forgot how to spell enemy. Uh, yeah, I guess N-E-M-Y. Did I spell it right? I guess I spelled it right. Yeah, my git. Push. Okay, let's see. Yeah, Kachinka baby. Okay, now let's fuck this entire thing up and try to build it again. I mean, the pipeline still exists. Trust me. Okay, what should I take care about now? I gotta delete fragment shader. Sorry, delete shader, fragment shader, and vertex shader. That's the point I was in. And this is my new GG. Okay, and if I just pull this on, and now I can read properly instead of split screening the entire fucking thing. I can read properly. So right now what I'm doing is like 0.5f 0.5f. Okay. And I'm generating the vertex array, generating the buffer. Why can't it have ah man, I like, you know what, like I have a plan in the coming uh screens. I'll probably go look at each of these functions and understand them, because without understanding them, if I move forward, I it looks troublesome. I don't know. Some part it feels like I'll fall into this pitfall where I don't know what's happening and what's the mistake. Like just like you pointed it out, if I forget to, list the number of triangles to be spun, uh, not making any sense. Number of vertices to be spun. Okay. So generate vertex array, bind the vertex array object first, then bind the set object one, then configure vertex array attribute. GL bind vertex array, okay. Bind buffer, okay. Bind buffer data. Ooh, chi. Buffer is basically just memory on the GPU, and you tell it how to access it. Ah. I mean, you're pretty knowledgeable, mate. I don't know how many years did you spend on this, but I mean, it must have taken a hell lot of effort to make this thing. Let's try making it. Uh, fuck, I forgot again. Am I supposed to? Let me guess. I forgot to mention the number of points. Okay, unsign it. Okay. Mm-hmm. 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 VAO. Shader program. Uh, okay. GL user shader program VAO and draw. Oh, bad. Not just draw elements instead of draw. GL draw. Uh, GL draw elements, not arrays. Elements and come on, be little bit. Okay, I'm drawing triangles. I know that. Uh, after triangles, what like triangle 6 and GL unsigned int and 0. 6 vertices. Uh, GL uns. Wait, unsigned int. Uh, 0. That's probably where I went wrong. Ah, fuck. Bind buffer was not declared in the scope. GL bind buffer. Bind buffer. GL bind buffer was not declared. What do you mean GL bind buffer was not declared? What happened? The GL header already included. Remove this includer. Okay, alright. Wow, weird number of errors for no reason. Yep, seems to be doing fine. Oh, yeah. But, like, is this my output? Is this supposed to look like this? Or is my screen might be too stretched for it? Even that's a fact. That's We got till the point where we created a rectangle. Minimize the number of vertices that we are spinning up, number of points that is being rendered. And now additional resources on rendering first triangle. I guess I'm actually understanding modern OpenGL and for free. Thank you. Yeah, probably should do that, man. This is wrong. No, I don't have my ad blocker enabled. Wait, just give me a minute. I'll resume. No. Pause on this site. Yes, pause on this site. I actually want advertisements in this, and I am really fine with viewing advertisements in this page. Yeah, see, I see error. No, I see what advertisements. Okay, shaders. Ooh, the topics that I see. Okay, let's see. As mentioned in a Hello Triangle chapter, shaders are little programs that rest on GPU. These programs run for each specific section of graphics pipeline. In basic sense, shaders are nothing more than program transforming inputs to output. Shaders are also very isolated programs in that they not allowed to communicate with each other. The only communication they have is via inputs and outputs. Nice. Okay. In the previous chapter, we briefly touched on the surface of shaders and how to properly use them. We will now explain shaders and specifically the OpenGL shader language in more general fashion. I mean, my reading got significantly better after starting Twitch or like streaming in general, because like back then I need to have this particular thing scrolling around, and I need to actually put my entire attention towards it, and it was kind of hard to think about it. I used to pass the entire file without actually caring about it. It's like I used to look at the paragraph and I somehow can make sense out of the paragraph and just move away. And right now I'm actually reading it, so it makes it more fun and achievable for me. You know what I mean? Like I never actually enjoyed reading documents, but right now I can. Shaders are written in C-like language, GLSL. GLSL is tailored for use with graphics and contains useful features specifically targeted at vectors and matrix manipulation. Shaders always begin with a version declaration, followed by a short list of inputs and output variables, uniforms, and its main function. Each shader entry point is as its main function, where we process any input variables and output the results in its output variables. Don't worry if you don't know what uniforms are. We'll get those shortly. Okay. Shader typically has the following structure: version, number. Okay, in type, in variable. Okay, out type, out variable, uniform type, uniform name. Okay, void main, out variable name, weird stuff. We proceed. The process input and do some weird graphic stuff that happens when we are talking specifically about vertex shader. Each input variables is also a vertex attribute. Okay, there is a maximum number of vertex attributes allowed to declare, limited by hardware. OpenGL guarantees there are always at least one 16 four, okay, at least 16 four component vertex attributes available. Sorry, it's 164 or what? Okay, 164. Okay, available, but some hardware may allow for more, which can retrieve by querying GL max vertex attribute. So I can just do this in the attribute the integer. Wait, GL where GL max, get GL integer. Mm, I like to party. Hmm. uh, I can just do it here now. Now I can just do this when closing. Just push this out for me so that make I open my triangle and I close it. Fucking I give it before the main loop. Okay. Maximum supported is 16. Okay, 16. Mm-hmm. This often okay. Types GLSLS, like any other programming language, data types for specific what kind of variables we want to work with. GLSL has most of the default basic types we know from the language, like C, int, float, W, unsigned int, and boolean. GLSL also features two container types that we will be using a lot, namely vectors and matrices. We'll discuss matrices in the later chapter. Vector GLSL is 2, 3, and 4. Got it. Components for any of the basic types just mentioned, they can take the following form and represent the following number of. Okay, vec(n), the default vector of n float. B vec(n), the default vector of n floats. B vec(n), booleans, integer, unsigned integer. Okay, I just guessed it, but yeah, unsigned integer, double. Most of the time we'll be using basic variant since floats are sufficient for most of our purposes. Components of a vector can be accessed via vec dot x, where x is the first component of the vector. You can use x, y, z, and w to access x coordinate, y coordinate, and z and w. Okay, to access their first, second, third, and fourth component respectively. GLS also allows you to use RGBA for colors or STQP for texture coordinates, accessing the same component. The vector data types allows for some interesting and flexible component selections called twizzling. Twizzling allows us to use a syntax like vec to difference vec difference x z by x. Okay, I mean, I guess I heard about this. I kind of read about this. I mean, I'm chicken necking right now. It means I'm fucking drained, but I think I can carry on for a bit more until I can get the shader up properly. Vectors are thus flexible data that we can use for all kind of inputs. Throughout the book, you'll see plenty of examples of how we can creatively manage vectors, ins and outs. Shaders are nice little programs on their own, but they are a part of a whole, and for the reason we want to have inputs and outputs on the individual shader so that we can move stuff around. GLSL defines the ins and outs keywords specifically for the purpose. Each shader can specify inputs and outputs using the keywords, and wherever an output variable matches with an input variable of the next shader stage, they'll pass along. The vertex and fragment shaders differ a bit though. Vertex shader should receive some form of input, otherwise would be pretty ineffective. The vertex shader differs in its input in that it receives its input straight from the vertex data. To define how vertex data is organized, we specify the input variables with location metadata so we can configure the vertex attribute on the CPU. We've seen this in a previous chapter as layout location equals 0. The vertex shader thus requires an extra layout specification for its input so we can link it with the vertex data. Too much information, brother. Too much information. The other exception is that the fragment shader requires a vec4 color output variable. Since the fragment shader needs to generate a final output color, if you fail to specify an output color in your fragment shader, the color buffer output for those fragments will be undefined, which usually means OpenGL will render them either black or white. Okay. My throat. This is good. This is really good. I never thought water would be good. You know what I mean, huh? Let me look at my friends. Before that, let me mute this. Ate? Ooh, pull up the party. Uh. Just give me a minute, I'm getting back. I got something I have to look at for a brief minute. I'll get back. I'll get back. Oh, yeah. Yep. Hmm. Okay. Uh, so if you want to send data from one shader to other shader, we have to declare an output and sending shader like a similar inputs in the receiver shader. When the output and the names are equal on both sides, OpenGL will link those variables together and then it's possible to send data between the shaders. This is done when linking a program object. To show how this works in practice, we are going to alter the shader from previous chapter to let the vertex shader decide the color for the fragment. Oh yeah, vertex shader. Okay, I'm location equals 0 and vec3 a position. Okay. What I'm fucking with the color right now? Oh bloody hell! This entire chapter is fucking with the color. But the problem is that I made my triangle a rectangle. Should go back? I don't think so, but probably I'll get something dumb. Man, hmm, I mean, if it still works with rectangles, imagine. Actually, I'm passing in the same shader for both. Okay, so, yeah, it makes sense. Yeah, you're right. You're right. I am enlightened by your wisdom. Thank you, Rob. Someday, hopefully, I mean, someday, hopefully, you'll start streaming and I'll join your stream and watch your stream. Do you stream, Rob? Let me check. You got 13 followers. No, you don't stream. I mean, you have abundance in terms of knowledge, so you can. I mean, you'll be a better streamer than me, man. Yeah. Yeah, I really think you'll be a better streamer than me. Do you think I'm good at talking to people? Nah. I just do this streaming so that I can keep a log on how bad I am at doing something. Quite frankly, like every good or great or mediocre guy who is starting to become good at something need to be grounded to at a certain point, and that's the same shit with me in web. Recently I started getting bored by writing more web. It's like it feels like a repetitive task of never ending boredom, because the problems that I face are they are fun at sometimes and they are pretty lame at sometimes. And it's been a long time since I took on something which kind of broke my head to figure out. And yeah, that's the base reason why I started streaming. I wanted to find few more difficult problems to live my life with. Take one problem at a time. Live one problem at a time. You know what I mean? Huh? I guess you know what I mean. Mm-hmm. The position variable attributes has positive. Okay. Let's just see. Why? Location void main. Okay. And wait, vertex shader, void main GL position, vec 4. I'm vec 4, and I'm giving one color, a pos, x, vertex color equals to. Okay, I'm giving an output here and sending like input, and this will turn out to be output, something like that. Yes, sir. Layout, yeah. Just do this. uh where is void main? Before void main, I need to do this, and inside void main I can just do gl pos vec 4, gl position vec 4, and a pos uh, of 1. I'm giving one color to everything, and vertex color to be 0.5 and 1.0. And uh, 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 vertex color to be what? Vec 4, vec 4 of type, like it's like 0.5 here, and 0.0, and 0.0, comma, what's this one? Okay, so if I do this mal masala, and in fragment shader, what do I do in fragment shader? Fragment shader basically same. And fragment shader, instead of frag colors, okay, input is vertex colors. So I just say, I in fragment shader, I mean, I don't think I need this. I can just do this uh, out of vec 4 vertex, in vec 4 vertex colors, vec 4 vertex color, and yeah, basically I can do this. Should I do a new line on every end line? Probably. Yeah, new line. Do I need to specify this? Okay. Oh, it's a C++ program. Why complicate it? Um, How that multi-line string works. We share an opinion. We are sharing a good opinion. We are sharing a good opinion. We'll just make this colorful. Hopefully, fuck colorful. Fuck the colors. Fuck colors. My fragments are broken. Oh, my fragments are broken. Fuck no. Fragment shader is broken. Vertex shader is broken. Rob, everything is broken again. I mean, I can go back. I can go back, but it's so fucking frustrating. So fucking frustrating, but it's interesting by the way. I guess I might have missed something here, like the way I'm writing my shaders doesn't make sense. I I, I hope I had your confidence. I mean, I bloody hate it. Like, is there any better way to write shaders? Like, is there any file type that shaders take in? Huh, folks? Anybody? Is there any file type that I should consider writing right now? Because all I see right now is and I don't think they're in the same context too. So I mean, how do I? Okay, wait. Out vec frag color. Okay, wait. There should be an example somewhere like where which I can use. Um, Probably you can if, you can see we declared vertex color variable at vec4 and set the point shader declare the vertex color input and fragment shader since both of the same type and same name in the I guess I have this wild guess since we are storing them like this, like I have a vertex source shader collecting this, I have a fragment source shader collecting this. Uh, they are built separately, binded separately. Is that the reason why I can't get vertex colors passed on to fragment shader? I do feel that's the reason for it, but there's no proper debugger that I can use. You know what I mean? I like to party. Uh, like, am I making sense right now? I don't think I made a real good point on explaining this one, but I feel that since we are writing shaders like in this way, that's the reason since this fragment shader constant is isolated from vertex shader source. How do I expect this to pass on till here? That's my point. I guess if we go through the example a bit more, I mean, if I just remove this part, it will probably do fine. Not exactly. It's a pain in the ass to load file. Okay, right? Let's see. Yeah, see. That's my point. Since fuck. I3, please, man. I3. Oh, fucking hell. I should find a better mod key for it. Find a better mod key to close a file. Like, oh, fuck you. Uh, Now I get alacrity, get out of the mood, and how do I switch? Uh, oh, nice. Resize, resize it, resize it. Do Tmux will get me back into my session. Hopefully, since Tmux is there with me, I am alive. You could say that. Let's just close this. We CLS? No. CLER is working. Okay. I mean, I'll figure out a way for it for sure. I mean, yeah, that would be a better point to take on. You know what I mean? Huh? I mean, by next time when we are here watching this, like not watching this for fuck's sake. I mean, I could figure out the main reason why it broke is because of this. I need to find a file type where I can write my shader classes and bind them together, or like I can just write shader GLSL. Okay, that would be my task before I stream next time. Hopefully tomorrow or day after tomorrow. Like I don't know. And like tomorrow is Friday. I just want to have fun, go out somewhere, have good dinner. Hopefully, yeah. That's most of what I want to do. Ma, 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 ma. Let's see. Oh, I can ask someone to collaborate with me. How does knock work in? How does knock work in Twitch? I don't understand. And how do you know that? Like just man, like I'm being outsmarted here, but I feel so happy that I'm being outsmarted here. You know what I mean? Yeah, like I'll dot GLSL file. Yeah, let's see. GLSL files. Mm-hmm. As far as an okay. Oh, oh. But like in Vulkan, did you have the trouble of using C++ plus plus or C? What did you use? I mean, I obviously feel oh, Rust like Volcano. This one. Uh, this one. Mm-hmm. I guess this is the one which I was pointed to by you, and we used to have this one more dude with us in the stream. Like that guy pointed it out to me. Like you can use Volcano, and I don't know, man. Like I like writing Rust, but it's too much effort for me. Like I don't know. Like at some point of time, I fell out of love. Mm, yeah, yeah, yeah. The thing is that like I really liked writing Rust for a bit, and after that, my day job kind of ruined it for me. It's like I preach what I like. That's the kind of person I am, and writing more Rust kind of got me into this phase where I've been an advocate for Rust for what, like 8 or 9 months straight, and I never actually tried the language. I just read about the language, and I knew what it does and what it offers. So I was pretty excited about learning it. But by the time I was getting good at it, by the time I was actually seeing some progress in my code, my day just screwed it for me, and people had opinions, and writing too Rust was like too cautious of an effort for me. You know what I mean? Like it's like I can write Go, C, C++ because of my practice or the time I spent in uh, with ease, and I understand what's happening there. But to dedicate the same amount effort for Rust, I don't know, man. I would probably go back after some time. Sometime I'll probably go back for it. Mm-hmm. I'm thinking of winding it up for today. Uh, where are we, by the way? But okay, I mean, we're almost there. But yeah, I'll do this part in my free time and I'll get back. But yeah, let's wind up for today. Like, it's 2 in the morning for me. That's my end line for every stream. I don't know why, but it's 2 in the morning for me, and I bloody feel sleepy. Acidity too. I hate acid reflux. Who doesn't? Okay. Yeah. Thank you for all the effort you put on my code. Not mine exactly. Like copy pasted code mostly here and then barely understandable. But without your effort, I wouldn't have gone through this. Oh fuck! I forgot to record this. Oh fuck! 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 Bye bye.